In this video, we will be reminding you or teaching you how to convert fractions to decimals. Now, looking at 4/5 and what is the equivalent form in decimals? Now, some of you already know that 1/5 is the same as 0.2. It's just one of the things that you've remembered. So 4/5 is going to be 4 lots of 0.2, which is 0.8. So there are some fractions that we can work out by just knowing what one lot of that fraction is. For instance, 1/2, 1/4. Some of you should remember 1/8. So these ones you can learn the equivalent decimals, and then from those equivalent decimals work out 4 lots of that fraction, or 3 lots depending on the question. But you do need a method for any type of fraction. So that's what we're going to look at now. Now remember that 4/5 is equivalent to 4 divided by 5. Remember we looked at that before in previous videos, that the fraction is the same as a division, or can be thought of as a division, and the division symbol actually looks like a fraction. So that helps you to remember that fact. So now we're going to say, well, how many 5s are there in 4? Because that's just asking the question a slightly different way. 4 divided by 5, how many 5s in 4? How many 5s go into 4? Lots of different ways of thinking about this problem. Right, there are no 5s in 4, so using our normal division technique, we have to carry that 4. Now we're already in the units, so now we're going to carry the 4 into the tenths. And now we're going to look how many 5s are there in 40. Now if you don't know your 5 times table, you should do, but if you don't, you can count up on your fingers, adding 5 each time, or if you lose track, you can always write them down. In an exam, there's no problem doing that, it doesn't take long. Look, I'm adding 5 each time. It just there's down in front of you, then you can use them. So there's multiples of 5. So how many 5s are in 40? Let's count along. 1, 2, 3, 4, 5, 6, 7, 8. 8 5s, 8 lots of 5 make 40. So the answer is 0.8, as expected. So 4/5 is the same as 0.8. Now that method works with all fractions. Okay, so let's look at another example. 3/8, for instance. That's the same as 3 divided by 8. Or how many 8s go into 3? So how many 8s are in 3? None. So the decimal point above the decimal point in the question, carry rid of 3. Then how many 8s are there in 30? Well, let's look at writing out our 8 times table, because if you know them, that's fine, but if not, you need another method. You can either use your fingers, but it's probably better to write them down, because you'll be using them quite a few times in this question. 8, 6, 24, I'm adding 8 on each time, 32, 40, 48, 56, 64, and you can keep going, but maybe we won't need to. And look, adding on an 8, that's why it's the 8 times table. So the next question is how many 8s are there in 30, as we said. Well, there are 3 8s in 24 and 4 8s in 32, so it's going to be somewhere between them. So we can take the lowest one, so there's 3, the answer is 3. And we wanted 30, not 24, so we've got a leftover, a remainder of 6, so we carry the 6. Okay, so we've carried the 6. Okay, next question. How many 8s are there in 60? Okay, so count along now. 1, 2, 3, 4, 5, 6, 7. So there's 7 8s make 56. And we wanted 60. So to get from 56 to 60, there's 4. So there's 4 left over. So we carried the 4. And how many 8s are there in 40? 1, 2, 3, 4, 5. Answer is 5. So 3 divided by 8 is 0.375. And all fractions can be converted into decimals in the same way. But so for some fractions, it does get a little bit more interesting. So let's look at 1 divided by 3, or 1/3, and see what happens with this one. How many 3's go into 1? Well, there's none. Carry 1. How many 3's are there in 10? Well, 3 3's are 9, so it's 3 with 1 left over. How many 3's go into 10? With 1 left over. 3 with 1 left over. 3 with 1 left over. 3 with 1 left over. And if we carried this on forever, we would just keep being left with 3 with 1 left over. And this is an example of something called a recurring decimal. You can see that this pattern will continue forever. So rather than actually having to write that out, we can write it as 0.3 with a dot above the number that recurs. So that's 0.3 recurring. So that means 0.333333 forever. Okay, that would never stop. So some fractions, when they convert to terminating decimals, and some to recurring. Look, this one will go on forever. So you just have to be careful. And when you're doing these types of ones, look to spot the pattern. Sometimes the pattern isn't obvious, sometimes it is. Particularly if you are doing sevenths, 2 sevenths for instance. Maybe you want to try that one. The recurring pattern is quite large. Just before we finish this video, let's have a look at recurring decimals and just think about how the recurring dot works. If I had 0.4 recurring, that's the same as 0.4444 forever. If I had 0.41 recurring, and I've got a dot above the 4 and above the 1, that's the same as 0.41414141 forever. Notice how it's now the whole of the 4, and this the 4-1 that repeats. The repeating pattern is a 4 and a 1. But 0.123 with a dot above the 1 and the 3, that's the same as 0.123, forever. Okay? So the first dot shows you what part of the pattern, where it starts, and the second dot shows you where the pattern stops. So you can see it's almost in chunks of 1, 2, 3 there. 1, 2, 3, 1, 2, 3, which corresponds to the 1, 2, 3 with the dot above the 1 and the 3. Okay, I hope that helps. You should be able to do most fraction conversions like that. It's a test of your division. Remember that if you can't do division, because you don't know your multiplication tables, your times tables, there's no excuse, because you can always write them out and use the list to help you find the numbers. If you still need some help, come and see us or watch the video again.